All right, solve the following system. And they really don't give us any guidelines here. And again, we're going to use a combination of substitution and elimination. I found with all three variables and three equations that elimination is usually what works best. You can come up with a number of plans. When I look at the x's, that looks like it's going to take, you know, some manipulation to cancel the x's. When I look at the y's, this is looking better. I've got a positive y, I've got a negative y, and a negative 2y. And when I look at the z's, that's also kind of the same thing. So my plan is to eliminate the x's, or sorry, the y's. And the way we do this is we have to combine all three equations. So the first thing I'm going to do is, I'm going to number them. And if I take equation 1 and I multiply equation 3 by 2, I'm going to eliminate my y's. So let's do that. And I'm going to multiply equation 3 by 2. And I get 2x plus 2y minus z minus 2z equals 0. Having a hard time multiplying and writing at the same time. Okay, so when I combine these, I get negative x, my y's go away like I planned, and I get a negative z is equal to, don't forget to combine your numbers, a 1. So I'm going to call that equation A. I'll come back to equation A. Now I'm going to do what I said, which was to take equation 2 and equation 3, and I don't have to multiply or anything, I just stack them on top of each other. So 2x minus y plus 2z equals 1, and equation 3, x plus y minus z equals 0. Now I'm labeling what I'm doing so it's clear to you, but I'm also labeling it so it's clear to me that I've worked with all three equations. When I get down to equation A and the equation B, I'm going to get out of this 3x, my y's go away, and plus z equals 1. Okay, so I'm going to call that equation B. Now, when I look at equation A and equation B, if I stack them on top of each other right now, I'll eliminate the z's, and I'm almost done with solving. So 3x plus z equals 1. Now, if it didn't eliminate, I'd probably have to do some multiplication, but this worked out really pretty nice. So negative x plus 3x is 2x. Z's go away, and I'm left with 2. So it looks like x equals 2. Now I start backing my way through my work to solve for the other two variables. For example, I'm going to go back to just the previous equation and solve for x. Either one of my previous equations, A or B. I'm going to use B because my variables are positive. That 2 in that I've already figured out, so I get 6 plus z equals 1. Finish solving. Looks like z equals negative 5. And now I'm going to look at my three original equations and figure out which ones looks the easiest. That equation 3, x plus y minus z equals 0. And I'll plug in the two numbers I have. 2 and z is negative 5. So 2 plus y minus negative 5 equals 0. So 5 plus 2 is 7. Looks like y is equal to negative 7. So we've got my three answers, x, y, and z. Okay, another system of three variables, three equations. Now this is pretty close to the way the quiz works. When they ask you this, you should probably expect that it's not going to have a solution. It's either going to be inconsistent or dependent. but let's see which one it is. Okay, when I'm looking at my x's, that looks pretty good. I could use the equation 1 to eliminate in both equations 2 and 3. Same with the z's, but since those are all negative and the x's are all positive, I think I'll go with the x's. Probably my best first strategy is going to be to take equation 1 and just multiply it by a -1. This will give me an equation that I can multiply by some numbers to eliminate with 2 and 3. So negative, x minus 2y, plus 2y plus 3z equals negative. All right, try that over again. Multiply equation 1 by -1. Let me just stop writing so much. Just confusing myself. Okay, so we're going to call this 1, and they tend to put a prime on it to say that it was modified, and I think I'll stick with that notation. Okay, so if I look at equation 2, it's got a 5 in front of the x, so I'm going to take equation 1 modified, and I'm going to multiply it by 5. That'll eliminate the x's. So 5 times -x plus 2y plus 3z equals -2. That'll give me -5x plus 10y plus 15z minus 10. So with that modified equation 1, modified a couple of times, I'm going to put with it equation 2. 5x minus 3y minus z equals 3. Eliminating my x's, I get 7y plus 14z equals -7. I'm just going to call that equation A, and I'll come back to that. I'm going to take equation 1, modify the negative, and I'm going to multiply that by 6. That'll help me eliminate the x's with equation 3. So 6 times -x plus 2y plus 3z equals -2. -6x plus 12y plus 18z equals -12. Okay. Combining that with, oops, now I move down equation 3. That, I'll get 0x, I'll get 7y plus 14z equals -7. All right, so equation A and B are exactly the same. If I take equation B and I multiply it by a -1, I'll get -7y minus 14z equals 7, which again gives me 0 equals 0, which is dependent. There's many solutions to the dependent systems. All right, went way over. Sorry about the long video.